So in many cases, you don't just analyze the system with expansion joints, you might have to also evaluate the expansion joint as it's being used in your system. There are a few ways you can evaluate that expansion joint, basically working off of the overall deflection and rotation of the joint. One thing you'll find on the vendor's catalogs for these expansion joints, as we show here from the Senior Flexonics Pathway catalog, non-concurrent motion. We looked at this earlier in our session when we looked at the demand on the joint. Well, now we're using it in the opposite sense. We have some calculated overall deflection of the joint from installed operation, and we want to go back and look at the catalog to make sure we don't exceed these values. What this catalog shows is non-concurrent movement. It would be non-concurrent axial, or non-concurrent lateral, or non-concurrent bending. Non-concurrent in the sense that you only have pure axial deformation, or only pure lateral deformation, or only pure angular deformation. Unfortunately, the joints in the field have some combination of these terms. So how would you want to combine the response? Can you do that? Well, there are two methods that are available. One is what we call a unity check, and the other is the Expansion Joint Manufacturers Association calculated equivalent axial growth. We'll take a look at both of these. The other issue, though, is that torsional rotation. I mentioned earlier that torsional rotation is very critical in these applications. Expansion joints don't take torsion well. So that is a separate calculation or check altogether. There is no combination of torsion with the other terms the way we see it in Seizure 2. Here's the unity check, the first of the two that I show here, unity check and the Edgemont check. The unity check, here's a quote from the catalog. It says, select number of convolutions based on movement capability and or spring rate. This is a simple iterative process. Utilizing the movement data for the size and pressure class required, compare the movement required with the movements available for a given convolution count. An acceptable design satisfies the following equation. And note we have here a ratio for axial, a ratio for lateral, and a ratio for angular movement. These are summed together. If these three ratios are less than 1, that linear interaction would say, or this unity check would say, the joint's okay. So even though the catalog might say non-concurrent, if the ratio of the three terms are all added together concurrently and it's less than 1, you're okay. So Seizure 2 has this check in it. If you go to the Analysis tab, you'll see Expansion Joint Rating. So you would run Seizure 2 or somehow collect the deflections of the joint, axial, lateral, angular, and also torsion, and then you can enter that data here in the Expansion Joint Rating algorithm. The other way that you can examine the overall deformation of the joint is the use of the equivalent axial growth method. This is published in the Expansion Joint Manufacturers Association. In the same way that you could take an axial stiffness of a joint and its length and effective inside diameter and calculate the bending stiffness and the lateral stiffness of the joint, you could also take the lateral deflection and bending rotation of the joint and convert that into equivalent axial growth. So the Expansion Joint Manufacturers Association gives us those equations that we can convert the other rotation and deflection into equivalent axial growth and compare that to the non-concurrent axial growth published in the catalog. So Seizure 2 does this check as well. So here we see the expansion joint data for the joint we have to look at here. We're using a 10-inch joint, 50-pound class, 109 inches effective area. And we show for the 12 convolution joint the axial deflection, allowed non-concurrent, lateral deflection, and the angular rotation. The catalog will also give us the angular deformation available for that joint. Here we show it right here. Now, you recall when we run the Seizure 2 modeler, the program shows us the stiffnesses of the joint, but this last column also brings in these data for the joint. So while we can see the non-concurrent axial, lateral, and angular, here they are from the Seizure 2 program, and there's our angular value. So if you're running Seizure 2, you may wish to write these numbers down because in the next step here, we're going to evaluate the overall joint deflection using these criteria. Now, one other item on the expansion joint, you have to consider the number of cycles that you're expecting over the life. These joints in this catalog are rated at 2,000 cycles. You should check with your catalog or the manufacturer to see what their baseline is. This is a page from the Senior Flexonics Pathway catalog, and the desired cycle life, if it's 2,000, the catalog reduction factor is 1. So if you have more than 2,000 cycles, you will have to basically derate the allowed deflections. In this case, if you have 3,000 cycles, instead of, if it was rated at 1 inch of deflection as non-concurrent, and you're running 3,000 cycles, you will then be only allowed 0.905 inches of deflection at 3,000 cycles. This is why getting the cycle count right is important, and also getting a good value for the calculated deflection. I shouldn't say calculated deflection. In reality, somebody should be checking this expansion joint hot and cold in the field and then use that to set the expectations of the joint. Again, if you have much higher cycles, be sure to derate the joint for higher cycle life. In a future session, we will exercise this expansion joint evaluation in Caesar 2 when we also run expansion joints through Caesar 2.